Today we have a short and simple tutorial on how to reverse engineer with GDB without looking at the source or the source debugging symbols, compiled with source debugging symbols. And I'm gonna show you how to analyze. So the first step of reverse engineering a software is to analyze your program. So if you don't have the source code or you don't have the time to compile or recompile your program, big ass program, with your debugging symbols enabled, or the program you're using is proprietary, then you gotta analyze how it works. So today's our target is gonna be on FFmpeg. So let's begin our analysis, shall we? So yeah, let me, for the sake of better visibility, let me just do that, and let's start our debugging session. Or if you want it more, you can do that. Alright, it's gonna be pretty clear now. So we are gonna debug our FFmpeg running on this plan. So let's start FFmpeg first. So we're gonna give a pretty simple command to basically automatically convert a MKV file or MP3 file into MKV, right? Out.mkv. We're simply gonna do that. So as you can see, there are a lot of things happening. First of all, you see this live this X264 codec, and it's rendering our frames by irregularly rendering our frame. And as you can see, it's not really rendering each frame numerically with sequentially. It's putting a lot of frame into a buffer and then printing it out. So what we want to do is we want to interrupt this process and run each of the each iteration by manually, right? That's what we want to do. So for educational purposes, let's see what kind of dependencies FFmpeg uses, right? So as you can see, so the main dependencies of shared libraries of FFmpeg are live AVCodec and live X264. So let me find it. I only have one hand to work with, right? So X264, and this is the linear address of where the references to the sections and the objects and stuff inside live X264 is located. So when the dynamic linker or the interpreter loads it, or the dynamic loader loads it into memory for execution, it tells the system to offset so to load the sections of live X264 into this address. So the first zeros are gonna be replaced with whatever the running address highest bit is set to. So this is it. So this so there are these two dependencies, AV codec and libx264. So we're gonna be taking a look at these two for things, these two shared libraries. So let's fire up FFmpeg inside GDB. So right, so this is what we want to do, and let's basically start it up with this flag, right? So R include out.mp4 out.mkv. It automatically does convert it without specifying the codec. So let's run that, and there is the first read from the stdin or interactive user input prompt, as you can see. So let's interrupt the program right here, and you see that it's libc's read system call wrapper function being called. And if you take a look at the backtrace, there it is. So the FFmpeg binary itself has only one function, only one symbol that is invoked when it's loaded into memory and for runtime execution. That is main. And for these other four functions in the call stack is not named, so it's hidden, and we know that it is in the FFmpeg binary because there is no external shared library references. It could be possible that the FFmpeg binary itself is using a static library or some sort. So yeah, we know that we have a main function that is the entry point. So let's delete our, so let's break at main and let's run it again. So yeah, it basically stops at main. And let's see, so let's disassemble the main function. So it's a bunch of assembly, right? And none of the functions that are being called, for example this one that is reference from the instruction pointer or program pointer to this, and it doesn't have any symbol names. So you cannot just set breakpoints to each individual functions. We have to do more work than that. Alright, so let's break it and find our main program. So let's continue and write yes and interrupt it. So at the time we interrupted the program, the program control was on AV buffer ref. Alright, so this is, let's see the call stack, and as you can see, it's called by the caller function AVCodexFrame. So AVFrame ref, then AVFrame buffer. Let's see, let's continue again and interrupt it. Let's see AVCodexFrame. So let's run it again, interrupt it. So at this, so it using libav format for now. So this is an odd entry. Let's continue it again and stop. Let's see the call stack. So AVCodexFrame, right? So as it appears that AVCodexFrame is a common function that are being that is being referenced in the loop. So what we want to do is set a breakpoint to this function. Let's run it again. Oops. I'm going to run it with the flags, or it's going to error out. And continue. Yes. And it stopped at AVCodexFrame. Let's continue and let's see what happens. As you can see, it's not really printing out anything. So it's probably possible that it is inside a loop to evaluate something. Then it gets to the main loop for frame printing. So what you want to do is look at the call stack and see the call stack. So it is the address, that is the stream instruction stream address where AVCodexFrame is being called from. So let's look at the instruction that is contained in this address. So we're gonna use X with a option I, and as you can see, it's not a call instruction. So in order to find out where AVCodexFrame is being called, we need to find the address where it's actually being called. But in GDB, what happens is that the address to where it's being called and the actual address that you get in the call stack is basically forwarded by one instruction. So you need to find out how many addresses are in between the instructions. So for example, this taking address lee instruction with this operands right here takes some. We need to find out how many opcodes there would be in this address. So for simplicity purposes, let's assume that it's 5 addresses, so we don't know. So 5 and no 6, and see that it's 6. So it basically contains 6 addresses for this instruction, and its operand included. So let's break. Oh shit. Here. And let's rerun. So let's delete the breakpoint first. And then set. And now we run it. And it stops at breakpoint 4. Now let's continue. As it appears, it's still not printing out anything. So let's take the backtrace and let's go to this function where basically, so let's apply the same technique. Let's see what it does. And it takes 5 opcode, and let's break here. And oh, I need to delete the breakpoints first so it doesn't break. And break at 6. And let's continue. Well, let's run it. And let's continue. Let's see if there's anything it's printing out to it. No, we see no frame information. So, let's do the same. And move also to X5. So let's break it at 5, and let's continue. No, I want to delete the breakpoints. Nothing. You know what? Let's rerun it again. out.mp4 include mp4 out.mkv, and let's see. AVCodexFrame. So let's break at this function, which is gonna be as address that, and 5. Why did I just shoot? Just to be sure, that's why I saw. Oh, let's break and continue. 10, 11, 12, 13, 14, 574. Now we can see that we have interrupted this. So it appears, so let's disassemble. Let's see this call stack. So it's basically calls from the caller main to this anonymous function to this anonymous function. So what if we break at this function? So it's basically breaking at this function. This is cool. Let's do the same here. Let's see what kind of instruction we have. Again, 5, and it's calling M0. Alright. I forget to delete the breakpoints every time. Now let's continue. Now results the same. So let's see where the loop is. So it's, oh my. Then it's test, and it's 605, right? It's calling from 605. So That's plus everyone. So we want to break at 5, 6, 7. So it's calls basically 2. Let's see if the instruction is correct. No, it's wrong. So 5, 6, 7. 3. Yeah. Let's first see. Pop RBX. Test. JNE. JE. We need to do more. So 20. Let's see if the calls are there. What the actual fuck? Let's clear the screen. Ah, man. Alright, D0. 8. Five. Let's see where it offsets to the main function. So it's 605. Now delete breakpoints. And break at main. And let's run it. Alright, so it's main 605. Let's disassemble it and go to 605. 605. There we go. So everything under here seems to be under a loop. So we stop right before the call. Yes. Right, I found it. Here is our function call. And let's see if it's under. No, it's not on a loop. So the entire function loops. Let's break it and run it again. Go to C. So as you can see, it's on a loop, conditional jump to main 518, so which is somewhere around here, 528. Oh yeah, the entire thing is in loop, but it's not in loop actually. This call right here. So let's jump forward one time. Let's see. Alright, that was a close call. My laptop almost died because of low battery. Now we're good to go. It didn't turn off, and we're gonna begin where we left off. Alright, so let's start GDB again, right? And let's run it. MKV, and our input, we always forget that flag. Alright, so as you can see, the rendering has begun. Let me shrink it so it shows the frame. Now so x264, it's x264, let's see. So it's invoked from AVCodec, which is this. So AVCodexFrame, and we have AVCodexReadFrame, as we saw in the previous section of the video. So this function is not necessary. The function that is called after main, called the first in the call stack from main. Let's break to that function call that calls the next function, because if we disassemble main, and go to the 605 offset, 605, where that is, I wonder what that is, 605. So it calls to this function. Let's break here. So let's copy the address and let's delete all our break. We haven't set any breakpoints. Alright, good. So let's break here. Right, we broke here. Now let's rerun it. Yes, continue. Wait a second. Yeah, it should have. Oh, I guess the jump. Let's list 10 instructions. 605. So let's jump right before here. Now let's rerun it again. Yes, breakpoint 1, but let's run it again. Breakpoint 1 in main. Let's see where that is. It's 598. Now good. It's right before the call. Now let's go after the call and let's see if it breaks before the rendering process is completed. Nope, it doesn't break. So we disassemble main 605. So this function right here handles the rendering process. So let's go into that function. Right, so let's start it again. Yep, we broke it at that place, and let's go. So this is the, now let's step. Oh, you fucking piece of shit. Excuse me. And we get to this function right here. So let's see our call stack. And now let's see the instructions of where we are in control. There is a call. Alright, let's jump right at the end. A little about here. And let's delete the breakpoints. And let's set a breakpoint at address this. Now let's run it. No, let's continue. It doesn't do this. Alright. It doesn't break. Let's delete the breakpoints. Disassemble main. Go to 605 and set a breakpoint here. Now let's rerun it. Yeah. Now let's go into that function. There we go. Let's try setting a breakpoint at RIP. So break dereference RIP. And please God. Oh shit. Now let's rerun it again. That was from start. That was breakpoint 6. Set at start. We can't do it like that. Let's try. Okay, I'm gonna do the most conventional approach, which is to let it run AVCodexFrame packet. Oh no. Okay, nice function. AVCodexFrame, and we want to break right here. So let's see what's contained in this address. Pretty easy. Go to the call, and now we want to break in the call. Now continue. Yeah, as you can see, it's so let's start it from the beginning. Continue, yes, and we set a breakpoint. All right, let's see what happens. Yeah, it's basically looping. The function is looping and it's doing a lot of work, making threads and stuff, and making the internal computations and configurations it's doing. And let's see when it starts rendering the frames. It's another thread. Now it starts rendering the frame. Let's see, 1, 2, 3, 4, 5, 6, 7. So it's putting twice. 10, 11, 12, 13, 14, 15, 16, 17, again 17, 18, 9. Let's see the break. So, what? Let's delete the breakpoints. Let's break at AVCodexFrame, right? Yes. Now continue. AVCodexFrame. I'm gonna break at this function call. Maybe then it will be sequential. Test so 5. Let's break there. Let's delete the breakpoints and let's break here. Now continue. Yeah, it's rendering multiple frames at once. Let's see. That's kind of weird. It's rendering multiple frames per day. So if you stop right here, oh, again delete breakpoints, you goddamn piece of shit. It's not sequential, there are duplicate frames as it's concerned, but it got to where it is. Now at the final stage, let's alright, should I do that? Alright, if you want to quit this video now, you might, but you might learn a bit about, might learn anything about FFmpeg. Alright, let's see. Let's run it again. Let's run it again. Yeah. So as you can see, this is initialized. So what you might be wondering what that is. That might be, so from my guess, I haven't looked at the source code yet. I might look at the source code and you may subscribe for that, for you to see this. So this might be an object that is the output stream. So it may be a struct that is the output stream that is being executed. So let's see what's contained in this address. So it might be, I will see just a decimal. So it might, there might, I don't know what the struct is, but I'm guessing it's a struct or it's a pointer. I mean, yeah, it's a struct. Definitely it's a struct. Now let's what I might do, yeah, so that might be a struct and it's loaded. Now let's rerun it again. So we haven't seen the message for the struct yet. Let's see if it's in memory. Yeah, it's in memory. So you might wonder, where is it really allocated? So let's delete all the breakpoints. And let's start at main. Break and main. Yes. And let's disassemble. Now you're gonna see I really forgot. We can't have regex search in GDB, that's a sucker. Alright, let's see. What I'm trying to find is a address ending with the hexadecimal 10. What the fuck is it? Oh shit. Oh no. Alright, we're gonna break at the call. Let's copy it and let's see if it's yeah, I guess this is the one. So this function right here, as you can see, if I try to get what's in the value, it cannot do that. But let's jump into the next instruction. Let's jump into the next instruction and continue. It's when called. Let's see if it's still not. Maybe this is this call right here. We don't have the value yet. Now we stop at the next instruction from where it's being called, and yeah, we are at that instruction, but there is nothing. So let's stop at this instruction. Still nothing. I think now let's go to the instruction below and see. Yeah, so as you can see, this function right here is responsible for setting up the object. Now you go that and you see that it's been set. So that was the tutorial for you. It's nothing good, just a basics on as to how you can analyze the program. So yeah, I still don't understand. I'm still frustrated about why there not been a lot of frames being printed out. But that's the analysis and basic analysis. There are a lot to reverse engineering. It takes even more time to create reverse the software than to create the software. So that is for the video. I'll see you in the next one.